right, so now in this particular video or this particular lecture, we're going to talk about ionic bonding, okay? Ionic bonding is the very, very first thing that we're going to talk about, and one of the things that we have to identify is the fact that an ionic bond occurs between a metal and a nonmetal on your periodic table. And in an effort to talk about this in a little bit greater detail, there is a simulation that I need to show you. And in order for me to show you, I need to back out of this for a second and go to this for a second. And now we are going to talk about this simulation. So this is an ionic bonding tutorial. And what I need you to do is simply put your pencils down and pay attention, which would require eyes up front and not on your paper.
Or your phone.
Okay, so
Texting.
Next. In this case here, the box contains two negatively charged ions. Do you see that? As a result of there being two negatively charged ions, what do you think will happen when I try to put them next to each other? Yes. They'll repel. Good. So that would look like this. I am making that noise. Okay? And if I do it really, really fast, they go really, really fast. Okay? Now, I broke it. Now, so what happens if I have two ions that are of opposite charge? They're going to do what now? They're going to attract. So here we go. Boom. Okay? So far, so good. And if I try to pull them apart, so far, so good with that. Okay? So we know that positive things are opposite charges attract and like charges repel. We learned about that last unit. So what's going to happen is that you have to understand these following three rules. Opposite charges attract and stick together. Alike charges repel each other, so they go apart. And so in order to build an ionic compound that sticks together, you need to have opposite charges, both positive and negative ions. Now, the deal that you need to remember is that looking on the periodic table, right, everything to the left, on the left side of the periodic table from this stair step line right here is considered a metal. So the orange portion is a metal. Yep. And the metals are always going to be positive. Metals are on the left, and they're going to be positive, okay, in terms of their ions. Now,
does that start at aluminum would be the first?
Aluminum would be considered the first metal. Germanium also, antimony, polonium, and then everything to the left is considered a metal. Okay? Pardon? Well, hydrogen is kind of does what it wants, but it's a non-metal, but it behaves like a metal. So we'll talk about that. Sodium is a metal, yes. What?
Hydrogen is a metal.
Well, no. So hydrogen is a non-metal, but it behaves like a metal. For lack of a better term, and I am not trying to be offensive in any way, shape, or form, it's sort of trans. Does that make sense? Okay. Now, the negative ion is formed from elements that have this tendency to gain electrons, and the nonmetals tend to gain electrons. So the atoms on the right side of the periodic table tend to be negative ions. Those are definitely nonmetals. Neon is a nonmetal, as is carbon, as is iodine. Okay. Did you have a question, Lily? Okay, because you did that, and then now you're doing this. So I'm not. I thought you did. All right, moving on. Okay. So far, we've learned that metals make positive ions, nonmetals make negative ions, and metals and nonmetals can bond together by forming an ionic bond. Now, what does an ionic bond look like? If we start with sodium and chlorine, a metal, which is sodium, and chlorine, which is a nonmetal, the chlorine atoms have a strong attraction for electrons because they're nonmetals. They want electrons. And under certain circumstances, the chlorine atom will grab an electron from a sodium atom, and that would look something like this. As an electron is ripped away from the positive from the sodium ion, it becomes a positively charged sodium ion. And the chloride chlorine atom gains a negatively charged electron, so it becomes what we call the chloride ion. So what that actually will look like is this. Oops, I should go back. So that would look like this. I did it again. Anyway, so here we go. Boom. That would be the electron that's being transferred. So note that when the electron is transferred, the sodium atom got a little bit smaller, the chlorine atom got a little bit larger, and that is okay. But now we have two oppositely charged things that we call ions. And those two oppositely charged ions are attracted to one another, and they're held together by this attraction that we call an ionic bond. What you saw was incredibly simple, so we're going to talk about how this works in the real world. If a human wanted to make table salt out of elemental chlorine and elemental sodium, they would need chlorine as a gas because that's how we find it at room temperature. It's also incredibly deadly. You would not want to inhale it, so you want to avoid that. And sodium is a chunk of metal. So what would end up happening is that if I take sodium and I get it hot enough, the atoms in sodium will vaporize and become gaseous sodium. And if I have gaseous sodium and gaseous chlorine, what they will do is they will find one another in that container, and they will attract one another and transfer electrons and then stick together. And as a result of them transferring electrons and sticking together, we now have this ionic complex, this ionic bond between sodium and chlorine. Now, if we go one step further, what ends up happening is that these two different sets of sodium chloride table salt actually will end up forming some type of a alternation of positive and negative ions. Positive sodium, negative chlorine, so on and so forth. And if I have a bunch of them in the right conditions, they will create what we call a crystal structure. So table salt, when you put it on the French fries or the mashed potatoes or the fried eggs, mashed potatoes. So when you put it, you're actually putting crystal onto your food, and when it goes into your body, it gets dissolved there. So this is the crystalline structure. Now, what? I have pink Himalayan sea salt is a very distinct taste that is different than salt, and it's expensive, and it's reserved for special dishes. Moving on. Now, it is because of the mineral, the minerals that make it pink is what, so it's different than. It is very pretty. Now, take a look. If I rotate this guy, do you see how it is this structure that it repeats red and blue, red and blue, red and blue, no matter how I rotate it? What we have there is we have this structure that is a three-dimensional crystal lattice structure. Now, I did that already. So because each ion is surrounded by oppositely charged ions, there are no distinct molecules, so we refer to this structure as an ionic crystal. Now let's take a look at what happens when we write these compounds. So here's my crystal, right? I'm going to click on these things. So my red sodium gives me 1 sodium ion, 2 sodium ions, 3 sodium ions, right? My blue chlorine gives me 1 chlorine ion, 2 chlorine ions, 3 chlorine ions. The ratio of sodium to chlorine is 3:3, and if it is simplified, it becomes 1:1. Good. So all we do when we write this formula is we simply take the ratio of sodium to chlorine, that's simplified, and write it as NaCl. So far, so good. Okay? There are no molecules in this ionic crystal. It is just crystalline structure. Now, looking at this guy. Look at this guy. This is calcium, and this is fluorine, and it is a giant conglomerate. Can somebody tell me, the calcium are the gray ones. Can somebody tell me how many calcium ions are present here?
Hold on. 8.
Calcium are the gray ones.
Oh. 4.
4. I agree.
I'm sorry. Can we all unplug? Because everybody has a phone out and headphones in. It's driving me crazy. You should not have headphones in and your phone out. Thank you.
Okay. So we have 4 calcium ions. How many yellow fluoride ions are present here? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So what's the ratio here of calcium to fluorine? What's the ratio?
4 to 8.
It's 4 to 8. And if we simplify that, what would that become? It could be 2 to 4. Could that be simplified even more? It could be 1 to 2. So the formula is CaF2 in this case. Okay? Now, so one of the things we saw is we saw that how ions form, we saw why they stick together, and how to write an ionic formula. That was the simulation. Now we need to go jump back into the notes and have a brief conversation about the rest of them. There's not many, so just bear with me. So here is how an ionic bond forms. We're back to the notes. You might want to draw this because this is definitely something that you're going to want to hang on to. So here I have a sodium atom, and I now have in my sodium atom here, and I have my chlorine atom here. And as they get closer and closer to one another, the chlorine atom has a strong enough desire to have an electron that it removes it from the sodium atom. That's what this is. This is an electron being removed. Oh boy.
Is that packet different than this one?
Where did you grab it from?
Right there.
It might be. My gosh, why can't I write today?
Are you still recording?
Yes. Yeah, I think you did too. I'll see if I can get you another. All right, so this is an electron being removed. An electron being removed. And then lastly, we have the sodium and the chlorine ions that are attracted to one another and being held together. Okay? So far, so good? So the definition of an ionic bond is the electrical force of attraction between 2 oppositely charged or charged ions bonding them together. So you should probably write this down because I'm pretty sure you have to fill in something for the ionic bond definition.
Can you go backwards?
Should that be in there? Should that be in the packet somewhere?
It is, right? It's in between the top boxes and the...
Found it? Okay.
Yes, I'll go back in a second. Or I'll make you watch the video tomorrow morning. I'm starting at this unit. I did not do it for the first one. So I will have one for everyone so you can go back and watch them. I will make one for the first one because Mr. Sussex requested it. Can I go now?
No.
Okay, now, how to draw an ionic bond forming. This is a skill that you are going to have to be able to demonstrate on a worksheet like tonight and a test like in the future. So, what? For what? What are you laughing at? Now
Oh my god. Charge? You said between 2 charges.
all right, now, step one. Step one says you draw Lewis dot structures for the individual atoms. I knew that sodium had 1 valence electron because the periodic table told me so. So I got this from the periodic table information. I also knew that chlorine had 7 valence electrons because the periodic table told me that as well because we wrote that stuff on top of the periodic table yesterday and today, right? Now, here's the thing that I think that you should know is that nonmetals attract electrons. So I should always see an arrow going from the metal to the non-metal. Okay? You need to draw that arrow that indicates a transfer has occurred. And then when all is said and done, based on the number of electrons that move from the metal to the non-metal, we now redraw our structure with the appropriate charges. Sodium lost 1 electron, it becomes +1. Chlorine gained 1 electron, it becomes -1. Does that make sense?
Yes, you can move on.
Well, I was going to ask if I could move on.
No.
Good.
The person watching this video might
Hey.
want to leave it.
Watch them. I don't
Isn't this our class? Do you end it?
No,
Or is it?
I'm going to leave the Idiocracy. What's that movie? What was that movie? Was that what it's called? Idiocracy? What?
Wait,
Absolutely.
stories, we can go back. and-
Although-
I didn't say any stories today.
All right, now we need to do this one together as a team. Hey, focus. Shh. We need to do this one together as a team.
No,
Okay.
Don't like this class. Don't like this.
So here's the deal.
I don't like.
I can tell from this formula here that I have how many calcium atoms present? Calcium, Ca.
No.
1. How many chlorine atoms present? 2.
Where do you see that?
Because it's Ca1Cl2. I know, it wasn't there. So just like in algebra, when you have x plus 3x, it becomes 4x. This one is implied. The same thing applies when we write chemical formulas. So on the thing that we did, the simulation, it was NaCl, but it was like, what's going on here? It was NaCl, but it was a 1 and a 1 because that's what the ratio was. Okay? So now, when I draw this structure down here, I'm going to draw calcium. And according to the periodic table, how many valence electrons does calcium have? According to the periodic table, how many valence electrons does calcium have?
Let's go look.
22.
How many?
It's 2.
It should be 2. So chlorine has 2 valence electrons. So I'm going to draw this. Okay? Chlorine has how many valence electrons? According to the periodic table. Has 7 valence electrons. And I'm told that I need to draw 2 of them. So I'm going to draw this. Okay. Now the next thing that I have to do is I have to show how my electrons transfer from the metal to the non-metal. So which one of these is the metal? Which one is the metal? Where is it on the periodic table? All right, let me back up. Is calcium a metal or a non-metal? It's a metal because it's on the left side of the periodic table. So this is a metal. What is chlorine then? Metal or a non-metal? It's a non-metal. And we just said that metals transfer electrons to non-metals, and the non-metals want to have how many electrons? 8. So I'm going to show that this 1 electron went here, and this 1 electron goes here. You got to do it. So when I redraw this, I'm going to draw my calcium with nothing. Okay? I'm going to throw some brackets around it though. And how many electrons did it lose? 2. So what's its positive charge going to be? it's going to be plus 2 because it lost 2 negative things.
So if it's minus.
If it loses an electron, it gets positive. Okay? Now, the chlorine, I'm going to draw like this. Yeah. That is an L. Now, this chlorine over here on the right-hand side, what did it do? Gain or lose electrons? It gained electrons, so what's its charge have to be? -1. It gained a negative thing. Okay? What about this one on the right-hand side? What did it do? Gain or lose electrons? It gained an electron, so it's going to be a -1. Questions?
Nope.
Okay. To be very clear, your homework is to do the worksheet WS3 ionic bonding. I don't think I have a copy of this in front of me. So it is,
2 pages.
oh my gosh, it is 2 pages. It is a front and a back situation. You have 1, 2, 3, 4, 5, and 6 and 7 to go. Okay?
That's a lot of questions.
It's not a lot of questions.
Unconstitutional and unconstitutional.
It is not unconstitutional, and I don't think you have a lawyer to sue me with. So,
I will, once I'm
I can buy a lawyer right now.
You don't buy lawyers, you hire lawyers. I don't
I
know where you
think
can buy
free and appropriate
lawyers at.
public education is suable.
Are you still recording?